Have you ever been amazed by how realistic and fluid some new 3D experiences can be? Especially when you can move around and see them from any angle in real time? Today we're diving into a groundbreaking technique that's making this level of fidelity possible: 3D Gaussian splatting. This incredible technology is revolutionizing the way we experience 3D graphics by allowing us to create highly detailed and immersive scenes with incredible speed and accuracy. Whether you're exploring a virtual world or navigating complex game environments, 3D Gaussian splatting is changing the game. But how does it work? Stick around and we'll break it all down for you. By the way, if you're interested in learning more, be sure to check out our website at Clonecast.com. You can find the link to our website in the description below, so don't forget to explore further. What is 3D Gaussian splatting? At its core, 3D Gaussian splatting is a method used to create 3D images by directly working with volume data. In traditional 3D rendering, objects are usually represented using surfaces made of polygons or lines. But with 3D Gaussian splatting, we don't convert the volume data into these surface shapes. Instead, it works with the actual data that describes the volume itself. This approach makes the process of rendering images faster and more detailed. While this may sound a bit technical, let's break it down to make it clearer. The concept of splatting was first introduced by Lee Westover in the early 1990s. At the time, this was a very new idea in computer graphics. Instead of using polygons to define the surfaces of objects, splatting used to overlap small shapes, or splats, to represent 3D data. These splats were used to give objects more depth and detail. Over the years, this idea has evolved, and today it has become the powerful technique of 3D Gaussian splatting. This method is now changing the way we render 3D images in real time, especially in fields like gaming, virtual reality, and simulations. It allows for faster rendering with much higher detail and quality compared to traditional methods, making virtual environments feel more lifelike and immersive. The challenge of real-time novel views. For a long time, creating high-quality 3D scenes that you could view from any angle in real time was a challenge. Traditional methods use meshes made of polygons and apply textures to represent objects. When you change the viewpoint, complex calculations are required to figure out how light interacts with these surfaces. This process can be computationally expensive, leading to issues like pixelation or slow load times. Generating novel views, perspectives that weren't pre-rendered, was particularly challenging and limited both the level of detail and the speed at which we could move in virtual environments. Introducing 3D Gaussians. Instead of using polygons, 3D Gaussian splatting represents a scene using tiny 3D shapes called Gaussians. Imagine these as blurry 3D ellipsoids, each with its own position, size, orientation, and color. These shapes represent the entire scene, offering a more natural and smooth rendering technique. The Gaussians are derived from input data, typically multiple photos or videos of a real-world scene taken from different angles. A process called camera calibration is used to identify sparse 3D points in the images. 3D Gaussian splatting fits these Gaussians around the points, creating a dense, volumetric representation of the scene. What's clever here is that these Gaussians inherently capture continuous volumetric radiance fields, meaning they don't just represent surfaces, they also describe how light radiates from each point in three-dimensional space, including its color and opacity. This gives us a more detailed and realistic scene representation. Direct rendering of Gaussians. Now here's where the splatting comes in. To render the scene, these 3D Gaussians are directly projected onto a 2D screen. Each Gaussian contributes to the color and opacity of the pixels it covers. Because they are inherently soft and overlapping, the blending between Gaussians is smooth, resulting in a more natural and detailed image. This method avoids the complex and time-consuming process of rasterizing polygons and calculating lighting and textures for each pixel. Instead, 3D Gaussian splatting provides a streamlined and efficient way to generate new viewpoints with incredible detail and speed, making it perfect for real-time rendering. Real-time novel view synthesis. What makes this approach truly remarkable is the ability to quickly generate novel views from any camera position within the captured scene. The continuous volumetric nature of the representation allows for fast, high-quality rendering from any angle. This opens up possibilities for truly immersive experiences where users can explore real-world environments in real time, whether it's a virtual tour, realistic avatars, or high-fidelity game worlds. How the Gaussians are obtained. To simplify the process, we start with multiple calibrated images or videos of the scene. Through camera calibration, we get a sparse 3D point cloud representing the structure of the scene. Then 3D Gaussian Splatting optimizes the Gaussians to match this data, adjusting their properties, size, position, and color to accurately represent the scene. Applications and future potential. The potential applications of 3D Gaussian Splatting are vast and exciting. This innovative rendering technique is opening up new possibilities in a wide range of fields. Let's explore some of the areas where this technology could have a major impact. 1. Virtual tours of historical sites. Imagine being able to take a virtual tour of a famous historical site or landmark, like the pyramids of Giza or the Colosseum in Rome, with stunning, photorealistic detail. Using 3D Gaussian Splatting, these sites could be captured from multiple angles and rendered in real time, allowing you to explore every corner of these places just as if you were actually there. You could walk around, zoom in on details, and see the site from any perspective, giving you a deeper, more immersive experience than traditional photos or videos. 2. Realistic avatars in VR and AR. In the world of virtual reality, VR and augmented reality, AR, having realistic avatars is essential for creating an immersive experience. 3D Gaussian Splatting could help create lifelike avatars that move and interact with you in a way that feels natural and real. Whether you're chatting with friends in a virtual world or interacting with a character in an AR application, the smooth and detailed rendering provided by this technology would make these virtual people appear as if they are physically present with you. This technology could completely transform how we communicate and socialize in digital environments. 3. High-fidelity game worlds. For gamers, one of the most exciting possibilities is the creation of high-fidelity game worlds. Using 3D Gaussian Splatting, game developers could create incredibly detailed and realistic game environments, where every texture, shadow, and object is rendered in real time with smooth performance. Whether you're exploring an open-world game or fighting in a fast-paced action game, this technology would allow for seamless, immersive experiences that feel more like reality. The ability to view the game world from any angle without losing any detail would completely change how we play and experience video games. 4th, digital twins of real-world spaces. Another groundbreaking application of this technology is the creation of digital twins of real-world spaces. Imagine being able to create a virtual replica of an entire building, factory, or even a whole city. These digital models would be incredibly accurate, capturing every detail and allowing users to interact with them in real time. This could be extremely useful in fields like architecture, urban planning, and construction, where being able to visualize spaces before they are built could save time and money. For example, architects could use these digital twins to experiment with different designs and layouts, and cities could use them to plan for future development or improve public services. While 3D Gaussian Splatting is still a relatively new technology, researchers and developers are working hard to make it even better. The goal is to improve its efficiency, quality, and versatility, which will allow it to be used in even more applications. As it evolves, this technology will continue to push the boundaries of real-time 3D rendering, making virtual experiences more immersive and lifelike than ever before. Key takeaways. To summarize, 3D Gaussian Splatting is a volume rendering technique using 3D Gaussian primitives. Enables real-time novel views from multiple images or videos. Represents a scene using soft, continuous Gaussians with specific properties. Blends these Gaussians efficiently to render new viewpoints. Offers significant advantages in speed and visual fidelity for real-world data. What do you think about 3D Gaussian Splatting? Are you excited about its potential applications in virtual experiences? Let us know your thoughts in the comments below. If you enjoyed this video, don't forget to like and subscribe for more insights into cutting-edge technology. By the way, if you want to learn more, You can find the link to our website, clonecast.com, in the description below. Thanks for watching, and we'll see you in the next one.